Hello everyone and welcome to the Game Engine programming series where we write a game engine from scratch. Today I'd like to add a new type of primitive mesh to the geometry pipeline, which is a UV sphere. I think this is an interesting exercise to also more thoroughly test the geometry routines. In the first part of this new episode, I'll write the code that will generate the mesh for the UV sphere, and in the second part, I'll compute the UV coordinates for the sphere and display it in the geometry viewer. I'd like to start by doing a little bit of cleaning up in the code. As you can see here, we have a couple of suggestions from Visual Studio to add a data context to this view. So luckily I can just go here and press Ctrl and period on the keyboard. And then I can choose the data context that we are using with this view, which is project. And you can see that it automatically added a namespace and the data context for design time. And we also see that there is some error here, which is a design time error. And if you go to project layout view, you can see that the error is here. It says that there is no default constructor for creating a project. And that's true. The project's only constructor expects a parameter. If we go to project class, you can see that the only constructor needs a name and a path. But we don't need to construct a new instance of projects for design time. And therefore we can remove is design time creatable, which effectively sets it to false. And that way you can see that the error is gone now. Let's try and see if it runs. Okay, it runs. And what I notice is that the hot reload is not available. And hot reload is something that's quite handy if you don't want to restart your application every time you change something in the XAML files. So for example, I could change the color of the background in the XAML file and then it would reflect immediately in the application that's already running. So that's a nice feature to have. To enable that, we go to Tools, Options, and normally when you go to debugging, there is a checkbox that we can check here. Hot reload. Well, it's already checked, and for some reason Visual Studio is not doing the hot reload. So what I often do is go to a site that's really useful, which is Google. You might have heard about it. And I type in hot reload WPF troubleshoot. Okay, it's suggesting the same thing that I just did, and that's not working. So I'm going to click on this one and see what's more in here. So this didn't work. And here they have an option in WPF project file that we can set to explicitly tell the compiler to include this debugging information for WPF. So I'm just going to copy and paste it. Go to Primal and Primal Editor. Here in Primal Projects, I can paste it here, for example, there. And when I go back here and rebuild the project, then it should work, hopefully. Now, as you can see here, hot reload is enabled. And if now I would go to project browser, like here, and change the background to, I don't know, magenta. Maybe not this background. Oh, that's the toggle button. The background of the window, maybe. You can see here that it immediately updates the background of the window. I'm not sure I like this color. I think I'm just going to revert back to the old one. But you get the idea. And other than that, I think we are good to start with implementing the UV sphere, because all we have right now is just a plane. And I would like to have something more complicated to test the geometry pipeline. further. So let's start doing that now. Okay, now I'll close all these files and open primitive mesh file. Now, like I did with create plane, I'm going to create a lot group and then have another function that I can call to create the UV sphere for me. Now we need to write the create UV sphere. Okay, the first thing I'd like to do is to actually show you what it is that we are exactly trying to construct here. Here in Maya, I can add a sphere and I can show you the properties of the sphere. If you look closely, you can see that a sphere consists of stacks of circles and vertical segments. And I could change the number of these segments that we have. Now, if you look closely, we can see that the only thing that we need to do is to have the poles, the vertices here, and the bottom one. And after that, we have just rings of vertices that we need to add. And luckily, we treated the spherical coordinates in the last video. So if you haven't watched that video, just click on the link in the video and go watch that one, at least the beginning part of it, where I explained spherical coordinates. And we can use the spherical coordinates to generate the vertices, which is the easy part of generating the UV sphere. And because I always confuse the longitude and latitudes, I'll just use phi and theta like I did for camera movement to denote the horizontal and vertical segmentation of the sphere. So the first thing we can type in is how many vertices we have along the phi direction and how many vertices we have along the theta direction. This is the number of vertical lines, which I take from the x component of the segments. So if you look at this sphere again, it's the number of these vertical lines, which go in the horizontal direction. That's why I'm taking the x component. So I'm clamping that between 3 and 64. 3 is the minimum. We can't have a circle that has less than 3. Here in Maya, you can see that they also limit the minimum number of segments to 3. Otherwise, we would have a flat shape. And the upper bound, which is 64, is just arbitrary for me. Feel free to change that if you want it to be higher or lower. And the second one is the number of circle segments in the vertical direction. In Maya, they also limited the number of vertical segments to 3. But in my case, we could have a sphere without this middle segment, which would result in a kind of double pyramid shape. And that's why, contrary to what's here in Maya, I limit the lower bound to 2 instead of 3. Next, we need to know the number of steps that we need to go around the circle. So here, for example, we have in the horizontal direction, like around the circle. In this case, we need 7 steps because we have 7 vertices in the horizontal direction. And one thing that we can conclude from this is that number of segments here is the same as the number of vertices that we have. And in the vertical direction, we have the caps and the midsection. So that's 3 segments that we have in this case. And also remember from the explanation from the spherical coordinate system that one of these angles goes from top to bottom, which is 0 to p, and the other one goes all the way around, which is 0 to 2p. And we need all this information to calculate the number of steps that we need. So in this case, I chose the vertical direction that goes from 0 to p to be the theta angle. So the number of steps is p divided by theta count. I'm going to add another constant in our math header file to just have 2p value in there as well. Now I can use 2p. Next, I'd like to calculate the number of vertices that we need. So if we look at this shape, you can see that we have 2 vertices at the top and the bottom. And the rest is depending on how many segments we have in the middle. And we can calculate that by taking the number of phi count and multiply that by the number of segments that we have, plus 2. In our example in Maya, the theta count is 3 because we have 3 segments, and phi count is 7. So we have theta count 3 minus 1 is 2, and phi count was 7. So 2 times 7 is 14, plus 2 is 16. So we need 16 vertices. Next, I'd like to create a mesh and put the vertices in there. You don't have to calculate number of vertices. You can just have these positions and add the vertices to it using pushback. But that results in additional memory allocations. When you have a lot of vertices, it can be a bit slower. So this is a faster way of just allocating the amount of memory that we need and then just putting the vertices directly in the array. Because we are putting vertices directly in this array, I need a counter just to know which is the next element in the array in which we want to put a vertex. And then we need to calculate the vertices in the mid section. I'm going to rename the steps to step because it's just the step value for each incremental step that we have. So it's just a step. Here we have a double loop, and the inner loop goes around the circle and the outer loop is the vertical direction. Because we already put a vertex in the top, we start at the second stack of circles and then we add the circle that belongs to this stack. And then we can just use the spherical coordinates again to calculate the position of each vertex. To calculate the sine and cosine of an angle, I am going to use a function from the DirectX math library, and therefore I'm just going to add a using here to use that namespace by default. As you can see here, again, the direction of z is reversed because we are using the right-handed coordinate system. And this way, all the vertices in the midsection will be added to the positions array. And the last vertex that we need to add is the bottom one. Please also note that I am incrementing the value of C after each addition of a vertex. So now that we have added all the vertices, I can check if the number of vertices is equal to this C. Now we have had the easy part. The next part that's a bit more difficult is to actually construct the triangles in the sphere. That means that we need to now fill in the indices, and we can also calculate the number of indices. We can see that we have the top cap and the bottom cap. And let me add another section in the middle. Like so. Now we have the top cap and the bottom cap, and the middle is just a ring. And the thing about the middle is that you can just open it along one of the edges and it will become a plane, basically. So we can use almost the same algorithm as we used for generating a plane. So now let's calculate the number of indices that we need. For the top cap, if we look at each triangle, you can see that there are as many triangles as there are vertices around the circle. So for each triangle, we need 3 indices. In this case, because we have 7 triangles, that would be 21 indices. And the same holds for the bottom cap, also 21 indices. And each of these faces will have 2 triangles, of course. Let me actually triangulate this. Now you can see that each face has 2 triangles, and therefore we need 6 indices for each quad in the midsection. So this part is for the top cap and the bottom cap together. And this is the rest of the indices that we need for the midsection. And this is -2 instead of -1 here, because we have the top cap and the bottom cap, and we need to subtract those segments from the total number of segments. Again, the way I'm going to add indices in the array is the same as we did for positions. So I'm going to use this counter again. I'll reset it to 0. So for the top cap, we are going around the circle and then just connect the top vertex to the 2 next vertices. Now we are going to go around the circles and calculate indices for each corner of a quad. If we go back and look at how we did that here for the plane, you can see that I calculated 4 indices for corners of the quad, and then I can add triangles by connecting those indices. And I'm going to do the same here. Remember that we already have added a vertex to the array of vertices, so we should always start at index 1. So here all I do is take one of these quads And for example, if this is our ith iteration around this circle, then here is the index I plus 1, I at the next row. So here is the j value plus 1, and here is I plus 1 and j plus 1. So this is the quad that we are working on. And all I do is just take these indices to form a triangle, and then we move to the next one. So this was the midsection, and the one that's left to do now is the bottom cap. For the top cap, we had the first index that was 0. The first vertex that we added is the top vertex, which has index 0. But we need to calculate the index for the bottom vertex. Again, the same as we did for the top cap. We connect the last vertex with the two vertices next to it. And here the I and I plus 1 are swapped because we are rotated like 180 degrees. So the winding of the triangles are going the other way around. Now we appear to be done with creating the triangles, and the next thing that I need to do is to add the UV coordinates. But I would like to first test the geometry and see if everything is all right, and after that we can calculate the UV coordinates. Because we need UV coordinates for the geometry pipeline to work, I'm just going to add fake UV coordinates here because it doesn't really matter what the values are for each UV coordinate. We have a couple of warnings here. And of course, we also need to return the mesh. The next thing that we need to do is to go in the primitive mesh dialog and add controls that we can use to generate the UV sphere. So before I make these controls for the UV sphere, I'm going to do a little bit more formatting here to make it a bit more pretty. Because I'm going to just copy paste these controls over, then I can just make some changes here and then copy them later. So I added a new style for the label controls that we have here. So I can just add a little title for each one of these categories and just made the background of each category a bit lighter. And I'm going to do that for this one as well. And then we are done. I can just copy this part over to the UV sphere. And then I'll change the selected item in this combo box as well to just go to the settings for the UV sphere. Right now we have some errors here because we have the same names for some controls because I just copied everything over. And we have the size parameters in the X, Y, and Z directions. So we need one more additional dimension here for the Z direction. And in the style trigger, that makes this part visible or invisible depending on what we have selected here. I need to also change this to UV sphere. And now we can see that we have everything that we wanted here. Next, we need to also go here in the function which calls the generation function and add some parameters for the UV sphere here. So this is a number of segments, obviously, and next I need to set the size in each dimension. And like we did for the plane, I give it a minimum size as well. We need to also add some textures here, but we are not using a texture yet. So I'm just going to copy this a couple of times. So this one was for the plane, and then the next one is for the cube, but we haven't implemented cube yet. And this one is for the UV sphere. Let's see what happens if I try to run the application. Okay, as you can see, we have something here that's black. And if I uncheck this show textured, then we can see that we have something here. And then I can increase the number of segments. It seems all right, but as you can see, it's missing one of the rows. And that's correct because although we went around the sphere to add the indices, we are actually not connecting the first vertex that we have here with the last index because all we did was to go around once, and when we arrived at the last vertex, we just stopped. And now we need to add another step that actually connects the last column with the first column in this sphere. So let's do that now. Now going back to the top cap, outside this loop, I add just another set of indices. That is just for adding the last triangle in the top cap. This is the triangle that connects the first vertex at the top to the last vertex in the first ring and the first vertex in the first ring. And for the midsection, because we are having one quad for each segment, we need to stay in the outer loop and then add 2 new triangles for each segment. These are the 4 indices for the 4 corners of each quad in each segment, and then I can just add new triangles for these. And for the bottom cap, again, 3 vertices to account for that last triangle. Now, as you can see here, we have a sphere and we can give it some segments. And because I just copy pasted these sliders from the plane, they are limited to 10. So I'm going to test our hot reload that we just enabled to see if I can change the maximum value for these. So going back to primitive mesh dialog and to those sliders, I can change the minimum value to 3, maximum value to 64, and for the other one it was 2 and 64. And now you can see that it was changed right away. This is it for today. I would like to thank you for joining me, and I hope to see you next time when I do the UV coordinates for the UV sphere. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus, there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering!